Math4Bronx, wake up! Today we're going to be looking at if a table is alive, which indeed I assure you it is. Look, this guy right here with the spotlight on him, he's alive. How, you may ask? Well, I'll show you. This thing is alive because of this. So let's say we have four scenarios. Let's say we have this scenario. So our first scenario is we have a gigantic 10-kilogram box. Now, I was in the situation, and it was very distressing for me because my table was so sad. Couldn't bear it. And here, the box is exerting its weight, which is going to be Fg. Fg is mg, m times 9.81. 10 times 9.8 is going to be 98 newtons. And then the table is exerting a normal force, which must be a force of 98 newtons so the table doesn't break. If the table broke, I'd be even sadder. So Fn must be 98 newtons. So right now, the net force is 0. But let's say somebody pushed on it with 40 newtons. That would make the table even sadder. Because not only is there still a force of gravity being exerted by the box, but there's also the force being exerted by the pusher, which would add a whole 40 newtons. So now, that means that the table would have to exert not 98, not 40, but 98 plus 40 equals 138 newtons to survive. And that's just sad, man. That's just so sad. Let's see if we could help the box happier, make my table happier. So, this box is exerting 98 newtons of force via weight. But the neighbor gave me a rope that I could use to pull. I'm not a strong guy, so I only was able to exert around 40 newtons. But at least it made my, because now the table only had to exert 98 minus 40 is equal to 58 newtons. The normal force was only 58 newtons to balance everything out. Happier. Now, I want you to make my table even happier. So can you figure out what's the minimum force required to make this table happy? Tell me in the comments below. Thank you everybody for watching, and I'll see you next time.